Alright, we're going to start out this course with a look at trigonometry. We start with trigonometry because it will help folks who are also taking physics during the same time, during the same semester. And what we're doing here doesn't require a whole lot of algebra. We're going to do some more. We're going to get into algebra a little bit later. And we're going to go over everything we need to know right in this chapter. And you might have done some trigonometry before, but we're going to begin just by talking about angles. Now, there's two sort of basic units we use to measure angles. We can measure angles in radians, and we can measure angles with degrees. And you're probably already most familiar with using degrees to measure angles, a full revolution being 360 degrees. Radians are defined in a more sort of natural sense by connecting the measure of an angle with the length of the arc that it cuts out of a circle. So here's a definition of a radian. If we start with a circle of radius 1, so that's really important here in this way that we define it, is that the radius is equal to 1. And if I cut out an angle theta, say, and then measure the arc that it cuts out of the circle here, this dark blue line, then the length of that arc is equal to the measure of the angle in radians. Now, alternatively, we can define a radian in this way, and we start with a circle again. But this circle can have any radius, so I'll say it has radius r. Now, if I take this length, the length of the radius, and then I say, okay, let's measure up the arc the same length. So whatever that length is, that's r, and then I connect this line back to the origin, back to the center of the circle to form an angle. This is defined to be 1 radian. So radians are defined by kind of connecting a measure of the angle or a measure of the arc it cuts out with the angle at the center of the circle. Since we can measure an angle in radians or degrees, there's a way to go back and forth, and that is simply the equivalence that pi radians is equal to 180 degrees. So here we have the 4 quadrantal angles. 0 degrees is 0 radians, and we always measure an angle. We say a standard position angle. We're starting at the positive x-axis, so here's the positive x-axis, and we measure counterclockwise from there. So 0 degrees or 0 radians means we haven't opened any angle at all. At the 90 degree mark is pi over 2 radians. If we go all the way around to the other side, we are at 180 degrees or pi radians. 3/4 of the way through is 3 pi over 2 radians at 270. And then if we come all the way back to where we started, 2 pi radians is 360 degrees. We can use that equivalence to convert angle measurements. So we're going to use this technique we call dimensional analysis. We're going to learn more and use it more in the next chapter. But basically the idea is that you can set up a unit conversion just by kind of chasing the units around. So here's what I mean by that. Since actually I'm going to scroll back up here, since pi radians is equal to 180 degrees, what that means, that gives us 2 fractions that are equivalent to 1. That means that pi radians divided by 180 degrees, well, that is, if pi radians is equal to 180 degrees, then when I do the division, that should be equal to 1. Likewise, 180 degrees divided by pi radians is also equal to 1, right? I've got some measurement dividing it by something that is equal to itself. And we can use that to do these unit conversions. So if I'm converting 30 degrees to radians, so I start with the measurement I'm given. I always make it look like a fraction. If it's not already a fraction, I make it look like a fraction by putting it over 1. Now, I want to get radians, and I don't want to have degrees in my answer. So I need the degrees to cancel, which means I'm going to put the 180 degrees on the bottom, the pi radians on top, The degrees cancel. We're left with radians, which is what we wanted. And then it looks like we can do a little bit more canceling. 30 goes into 180 6 times. So we have pi over 6 as an exact value, pi over 6 radians. And if we want to approximate pi, I hit the second button with the up caret. See, pi is in blue here. And that'll bring up pi divided by 6. And 0.524 radians. If I can be exact, I usually am, so I usually would kind of leave it there. Alright, next we have 3.7 radians. We want to convert this to degrees. So 3.7 radians, I'm going to make it look like a fraction by putting it over 1. And I'm going to multiply by, I guess I didn't really kind of point this out before, but the reason we're multiplying is because this fraction here, right, that's equal to 1. So I'm multiplying that 30 degrees in part A, I'm multiplying that by 1, which means I haven't changed it. I haven't changed what it's equal to, I've just changed what it looks like by giving it different units. So I'm going to do the same thing down here in part B. I've got radians. I don't want radians in my answer, so I'm going to put the radians on the bottom. Pi radians, 180 degrees. The radians cancel. We're left with degrees. And now I'm just going to multiply through. So 3.7 times 180 and then divide by pi, because pi is on the bottom. We get 211.99 degrees. Okay. We'll make use of radians. We'll use radians a bunch when we do some application problems, and we do most of those actually in the next semester, applications that involve arc length and area of a sector and uniform circular motion. For now, we're going to work mostly with degrees and dig a little bit deeper, and we can actually split up a degree into smaller units, and we call these units minutes and seconds. And before I talk about the minutes and the seconds, I'm going to just sort of bring up something that we're all pretty familiar with. Let's say I measure out the length of, I don't know, a board or something, and I find that it's 6.25 feet. So that's 6 1/4 feet. Now, I might write 6.25 feet, but that would be the same as writing 6 feet, and 1/4 of a foot is 3 inches. 6 feet, 3 inches. So here we have two different ways, right, to indicate the same measurement. And I haven't changed units, really. I haven't changed, like, I'm still using the imperial units of length. I'm still using feet. But it's just sort of like how I chose to represent this fraction of a foot, right? So I could represent it in the decimal form over here on the left, or I could convert that decimal form into a smaller unit into inches on the right. And we're going to do the same thing here with degrees, minutes, and seconds. So we can split up a degree. 1 degree is 60 minutes, and we use the single kind of dash mark to represent a minute. And 1 minute is 60 seconds. We will use the abbreviation DMS to refer to degrees, minutes, seconds, to distinguish it from degrees in decimal form. So in example 1.2 here, we want to convert 315.87 degrees to DMS, to the nearest second. So we have an angle that's given to us in degrees in decimal form, and we want to convert it to DMS, to the nearest second. So I know that my answer is going to look like so many degrees, so many minutes, so many seconds. And it's a whole number of seconds because it says to the nearest second. So I already know part of it, right? I know that the whole number of degrees we have is 315. It's just converting this 0.87 degrees into minutes and seconds. So I just don't know how many minutes, how many seconds, and that's what we're going to find out. So the first thing I'm going to do is convert 0.87 degrees to minutes. So 0.87 degrees. I'm going to use that dimensional analysis that we used when we were converting between degrees and radians before. So 1 degree is 60 minutes. I'm going to put the degrees on the bottom. So the degrees cancel here. I'm left with minutes. 0.87 times 60 is 52.2 minutes. Now, what I'm going to do is take the whole number of minutes. Even if that were 52.9, I'm still going to take the 52, right? So ignore the decimal part here. Take just this whole number. That's what goes here. 52 minutes. And then I take the 0.2 minutes and convert that to seconds. So let's see, 1 minute, I put that on the bottom because I want the minutes to cancel. 60 seconds. So 0.2 times 60 is 12. So I didn't have to round that, right? I got a nice whole number. If I had gotten a decimal here, like 12.3 or 12.8, I would round it to the nearest whole second. So I don't have to do that in this case because I got a whole number as a result. And this is the measure of the angle in DMS form. Now we're going to go the other way. Here they've given us an angle in DMS form, and we want to convert it to degrees in decimal form. So I know that I have 7 whole degrees, right? And then plus 16 minutes and 23 seconds. So I know my answer is going to look like 7 point something degrees, right? It's just knowing what is that decimal part. So when I approach these, I start with the smallest bit, right? I start with the number of seconds, and I figure out how many minutes is that. So 23 seconds. I'm going to convert that to minutes. 60 seconds. This time the seconds go on the bottom to 1 minute. The seconds cancel. I'm left with minutes. 23 divided by 60 is 0.3833. Obviously the 3's go on forever, but I'm going to take it out. I think that's 4 decimal places ought to be enough. 0.3833 minutes. So that's how many minutes I have in 23 seconds. So what I'm going to do is add that fraction of a minute to the 16 minutes that we already have. So we have 16.3833 minutes in that fraction of a decimal there, or fraction of a degree. So I'm going to take 16.3833 minutes and I'm going to convert that to degrees. 60 minutes to 1 degree. The minutes have to go on the bottom. So 16.3833 divided by 60. .273055. So that's the decimal part of the degree. Of course, that's going out quite a bit. I think a lot of people would round it probably to like the 1,000th place. I think if you have it to the nearest whole second, it's conventional to take it out to the 1,000th of a degree. Alright, so there's some angle conversions, getting used to measuring angles in radians, in degrees, in decimal form, and in degrees, minutes, seconds.